All right. Well, I'm with Kyla Wood, and she is with Applied Polymer Systems Inc. And Kyla, why don't you tell us a little bit about the company, what you do with the company?
Sure. So Applied Polymer Systems, we manufacture and provide anionic polyacrylamide-based products for erosion control and stormwater treatment. Our company has been around since the early 1990s. We kind of developed this passive treatment technology in the mining industry, and we moved down to the southeastern United States in the early 90s to treat turbid construction runoff, and we've just kind of grown from there across the U.S., a few different places globally, and again, we do environmental applications for water treatment and handling suspended sediments.
Okay, and your role with Applied Polymer Systems is what do you do?
Yeah, so my major role, we are, we're a smaller company, and so we wear a lot of hats. But specifically, what I do is I do research and development, and I handle a lot of the training, education about flocculants and PAM specifically, and then I do a lot of the regulatory work with different states and what they require and things like that.
All right. Well, thank you for joining me in talking about passive treatment, or sometimes it's called inactive because we've been in the permit, we've had active treatment. So now with the new attachment G and the new CGP, we have a new area. In fact, a lot of people don't know about this. How does inactive stormwater treatment differ from active, or passive from active? What's the difference there?
Sure, yeah. So, passive and active treatment systems really have the same goal, and that is to use flocculants or coagulants in the system to take out turbidity, TSS, and essentially, treat water. The major difference is that active treatment systems, they're a much more mechanical engineered system they're typically much more expensive, and they are going to have meters, pumps, manifolds, tanks, filters, residual monitoring. And there's really some, especially on the West Coast, the active treatment systems are really popular. And so if you look at, Washington, Oregon, California, you're going to see a lot of specific requirements and training involved in those active treatment systems. So the passive treatment systems, a lot of times we use similar materials like the flocculants and the polymers and things like that, but these are not as engineered. And what we're typically doing, it doesn't mean that we don't use pumps and things like that. We can use them with gravity flows, but we can also use them with pumped water. But what we're doing is we are using the polymers with kind of existing BMPs on site and treating water with those flocculants in a much more cost-effective way without all that extra equipment, power, sometimes clean water. So that might look like it's in a channelized area with a flocculant log, or it might be treating wattles or rock checks with a flocculant powder. We're going to enhance those existing BMPs in a much more cost-effective way than those very big engineered specific systems.
Okay. And I understand, at least in reading the permit, about active systems and then passive treatment. Now, one of the big differences is what type of polymer they use. Active
Right.
treatment can use cationic, and passive is only allowed to use anionic. Could you tell us the difference between those two polymers?
Sure, yeah. So that's charge is really kind of the one of the most important aspects because it governs the safety and the aquatic toxicity of the polymers. So in an active treatment system, we are filtering out those residuals, we're monitoring them, and so we're making sure that you can use some of the all those different materials because nothing's going to be escaping into the environment. So with passive treatment systems, we use these anionic flocculants because we're going to be doing work that's directly kind of in the environment. We're going to technically be collecting the particles and the floc and the polymers and the sediments, but we are, in the open environment, and there's a potential they could reach receiving systems. So how that works is cationic polymers fish have negative charges on their gill surface. And you're probably familiar with that concept that opposites attract and like charges repel against each other. So with cationic or positively charged polymers, those will attach to the surfaces of fish gills, and they can cause suffocation at a really small amount. So about the same amount that you need to treat water, you can actually cause toxicity to fish. So you have to be really careful about putting that into a situation in the environment where it could reach any sort of receiving system. Now, anionic polymers like the polyacrylamides, those are negatively charged and those will repel against the surface of gills. And so they're very, very low toxicity, and the amount that we use is going to be safe for those aquatic organisms. And, California doesn't allow this specifically, but, we do work with ponds and things like that. And we've actually used these directly in koi ponds and trout streams in Michigan. So they're very, very safe material, which is why they're letting you use these or requiring you use these specifically for passive treatment systems. Because if something were to happen, it discharges into a stream or a river, it's not going to cause toxicity.
Okay. But I understand that the soil particles, or at least small clay particles, also have a negative charge. How would a negative polymer help with that? Because, as you mentioned,
Yep.
opposites attract, but
Yes.
like charges repel. How does that work?
It's a great question. So if you look at the CGP and a lot of requirements for PAMs, it also requires a specific size of polymer. So the anionic polyacrylamides are really, really large molecules. So in addition to being able to kind of electrostatically or chemically bind to particles, their physical size allows them to bridge multiple particles. So even large sized non-ionic or neutrally charged PAMs can bind to sediments and metals. So it's a really cool material that's able to bind anionic PAMs. These negatively charged PAMs are really effective at taking out suspended sediment like clays, and they can also take out positively charged things like metals. So it's this really, really effective, unique material that's able to target those without being toxic to fish.
Okay, so it's using electrochemical, but also maybe physical.
Physical, yeah. They call it bridging, like a bridging reaction or a physical binding. So it can do both those processes and take out multiple different charge types.
All right. Now, you mentioned several ways how your product is used, but at a construction site, what would be some of the tools that you might give to a contractor to help control their turbidity?
Sure. So there's really, the PAMs are really versatile, and there's a lot of different things that we can do with them. Dust control, soil thickening, things like that. But what we're talking about right now and what we use most often them for is erosion control and soil stabilization, and then again, water treatment. So the way that those would be applied for erosion control and soil stabilization, you can apply them to a bare or disturbed soil surface. And I like to say that it's kind of all about agglomerations for both soil treatment, soil stabilization and water treatment. That polymer is going to go out onto the soil or into the water. It's going to bind to the soil surface and form an erosion resistant surface. So if rain or water or stormwater runoff hits it, it's not going to become mobilized and eroded off the soil surface. So it's really great, for soil stabilization. One thing we like to say, and this is actually a point that they make in the new CGP, is that you're not supposed to be, using this in place of your existing BMPs and your physical BMPs. And we like to stress that as well, that this is really an enhancement. So we would almost always suggest using it with, matting or other cover or things like that, and helping that work better by holding that to the soil surface and keeping those really fine colloidal clays from running off. For water treatment, it's kind of the same concept. We're going to put it in flowing water that might look like the flock logs or those solid gel logs. And as water flows over and around them, they're going to dissolve, bind up those particles, form bigger, larger flocks. You're going to use those in conjunction with sediment basins, sediment traps, other ways to collect those particles like rock checks, silt fence, things like that. And then the granular polymer can also be used for water treatment, and you can enhance your sediment control devices like rock checks, wattles, and instead of just dropping out heavier sediment, by treating those with a flocculant, like a PAM, you can actually turn those into clarification devices. So there's a lot of ways we can use them, but those are kind of the key ones in most applications.
So these flock logs you could put in swales and conveyance systems that water could pass through it. Does it actually permeate through it?
So what they do is they don't. I like to we refer to it kind of as soap on a rope. So it's about an 8-pound log with a biodegradable, coconut core and a rope that comes off of it. So you'd stake that rope into a channel, some type of flowing area like a swale, and it's going to slowly dissolve. Typically, it takes about 1 to 2 million gallons of water flowing over it, and then it'll completely dissolve down to the coconut skeleton. There'll be nothing left and you'll replace it. So it dissolves slowly. Once the polymer's in the water, it's kind of like this snowball effect where the polymer then contacts the sediment. It takes about 30 seconds of mixing once it's in the water, and it's going to bind more and more sediment until it forms these big flocks or agglomerations, and then they'll be heavy enough to kind of rapidly settle out.
So you'll also need some sort of settling or device after that, a settling basin or check dams or something to encourage the flock to settle.
Yeah, absolutely. And if you think about it, the reason we're using the flocculants is to prevent sediment and other contaminants from escaping off the site. So, it's kind of the same concept. If we are going to turn them into these bigger, larger flocks, but then continue to send them off site, we're not, doing what we set out to do and keeping that sediment on the site. So we still have to collect that sediment. And like you said, whether that's a basin or a rock check or, a silt fence or something like that.
Okay.
Or dewatering egg.
Okay, now can the granules or powder version be mixed right into a settling basin or holding pond?
So some of the most important things that are going to make a flocculant work is mixing and reaction. So if I were to just apply a log or a granular to a basin that didn't have turbulent mixing, then it's really not going to it's not going to have a chance to contact that sediment and create those big flocks. So you might have a little bit of reaction, but really you're just going to kind of have unused polymer probably falling to the bottom. So that's why it's really important to treat those in kind of channelized areas before it gets to the basin.
Okay.
Now that's ideal, but we often see turbid water in a basin that we need to treat before we can discharge. So you can still do that by setting up some type of recirculation system. So again, it's passive treatment, but that doesn't mean we don't use pumps in a lot of different instances. So we can pump the water out of the basin through kind of a flocculant treatment system, whether that's a channel or a swale that we've built, or in many cases we can use pipe systems where we insert the flocculant logs directly into pipes, and it's going to flow through PVC, mix and react, and then discharge back into the basin. So those are all passive treatment options to treat already turbid water.
All right, yeah, that makes sense. So Kayla, I know this technology is new to a lot of people in the state of California. How can they find out more information about your products and what's available?
Sure. So as I mentioned, we've been doing this for almost 3 decades now, and you can kind of imagine, if you've seen these materials work, it's almost, you put this powder in a water, you mix it for 30 seconds, and you go from 500 NTUs to near drinking water. So when we brought that technology down to the Southeast, people were like, it's magic. There's no way. So we've spent a lot of time providing training and education and resources. So what I would suggest doing is, if you reach out to us, we have a 3-part engineering. We have a lunch and learn series that we kind of share with everybody. We worked with IACA to do just recently, earlier this year, a 2-part flocculant training webinar. And so we are very, very training based, and we're happy to work with anybody who reaches out to us to provide training and information on the flocculants. So I would certainly suggest reaching out, and we love to, spread the information and teach people how to use them safely and effectively.
Okay. Well, an attachment G of the new permit actually requires that there be a certain amount of training and a certain amount of oversight. Two things, they want a passive treatment plan, and then also that personnel that are speccing it, using these polymers, they need to be trained. Is that something you can help contractors with who might be interested in using some of your products?
Sure. So I reached out to a few different people at the water boards, some of the universities and engineering firms who are kind of involved in this whole process from the beginning. And right now, it sounds like there will be some type of state-specific training, kind of similar to what they have for the active treatment systems. But right now, it has not been nailed down as to what they're going to accept in terms of that training. So they did say that they will be doing that they're doing a video series that's going to be coming out the middle of next month, that's going to show and talk about these new pieces of the CGP, and that'll have then kind of the next step of information on that. So right now, unfortunately, I don't know specifically what that training requirement is going to be, who can put it on, what they'll accept. Right. But as we kind of just mentioned, if it's not available yet and you want to get jump started on what passive treatment is, how flocculants work, why we're using the ones that we use, different BMPs, how to set them up, that information, we're, again, happy to share that, but I can't say that it's going to be something that is considered the training needed by the state of California at this time.
All right. Well, that's great information. Kayla, if people have more questions, I'm sure they can get a hold of you. We're going to put your contact information at the end of this video where they can reach you. Thank you for your time and just expertise on this new area, at least for California. Of course, I know there's one group in California who's been using it for quite some time, and that's the farmers. They've been using PAM in their row crops for quite some time. And see similar results, that it really turns turbid water into very clear water.
Yeah, I always use the USDA as, if you want more information about PAM. They've been doing it since the 1950s. There's current videos about it, so they're a really great resource and have done a lot of work on PAM for erosion control and improving crop yield and vegetation growth and stuff like that. So yeah, absolutely.
All right, well, thank you again for your time and helping us understand a new area, passive treatment.
Yeah, absolutely. Thank you so much for having me. It's really exciting now that we're, moving into other areas. So